Hello there. In the last video we looked at building a number guessing game. In this video we're going to step up the complexity a little bit and we're going to build a word guessing game. So just like before, we're going to use comments to plan our program, and if you've ever played the game Hangman, this is going to be pretty similar. So the first thing we're going to want to do is print some instructions, basically the same as any program we'd write really. We're going to think of a word, and then we're going to let the user guess the word one letter at a time. I'll just make this a little bit wider so the text doesn't wrap so much. Okay, so I'm actually going to leave it there for the planning for now, and then as we write more code I'll add some more comments to explain what else I want to do. So print some instructions, that should be pretty easy by now. We've used puts several times in the last couple of videos to do just this. So I think just about the most concise way I can put these instructions is to say guess the word one letter at a time. Then we need to think of a word. I'm going to have a variable called word, and I'm going to say equal to, let's say, monkey. And then let the user guess the word one letter at a time. So to do that we're going to use a loop, just like in the number guessing program, and I'm going to say they have 10 guesses. So we'll say 10.times space do, and I'll put end in before I forget. So I've written code for all of the comments that I had so far, and now I'm going to go back into planning mode and think about what I need to do each time we run through this loop. So strangely, the first thing I actually want to do is show the user's progress. So when the user hasn't guessed any letters, I want to display dashes in place of the letters. So we've got M-O-N-K-E-Y as an example. That will be how things start off. And if the user has guessed, say, the O and the K and the E, but not the Y, it would look something like this. So that's what I want. And we need to get a guess from the user. We need to check if the guess is in the word. So they're going to be entering characters one at a time. We need to check if they're in the word, and if they are, we probably want to store them or keep track of them. And then probably the last thing we want to do is check if they've won, if they've guessed all of the letters. So looking through these comments, there's some of them I don't really know how to do yet, but I don't have to fill things out in order. And probably just about the easiest thing to do here is to get a guess from the user. We've done something like that in the number guessing program and in the program in the first video before that, so this should be pretty easy for us. So I'm going to have a variable called guess, and because this is just a piece of text, I'm going to say gets.strip. If you remember, the strip method of strings removes all of the invisible characters off the either end of the string. So that was pretty easy. The next thing that leaps out at me really is check if the guess is in the word. And to make this a little bit easier, I'm actually going to come back up here to where we set our word variable. I'm going to write this: letters equals word dot split space, and then just some empty quotes. No contents in there at all. And to show you what that does, I'm going to write some code over here in the right hand side, and let's say I had the string A, B, C and D with commas separating them. If I use the split method with an argument of a comma enclosed in quotes, you can see it breaks things apart, and there's a square brace on either end. And what this is a list, or you might call it an array if you're being a bit more programmery about it. So what the split method does is split apart a string by some delimiter. Now in this case we have the word monkey, and we want to split it apart by, well, actually the nothingness between the letters. So by giving it an empty string as its argument, you can see the word gets split apart into its individual characters. And that's exactly what we want to do. And we've done this because it's going to be really useful for checking if the user has guessed a correct letter, but it's also going to become useful later on when we're checking if the user's won or not. So checking if the guess is in the word now becomes a little bit easier. So we're checking something, so we're going to need a conditional. And what we're going to do is use a particular method that lists or arrays have in Ruby, which is this one, the include with a question mark method. This is a way to ask if something is included on a list. So we're going to ask, does the list of letters include the guess? And if it does, we want to store the guess somehow. But at the moment we don't have anywhere to store it. So what I'm going to do is, before the loop, create an empty list, which is just an opening square brace and a closing square brace, just like the square braces on these lists when we were demonstrating things over here on the right hand side. And we can use this list as a place to put things. And the way we do that is to say guesses.push space guess. So the push method of lists is a way to add things onto them. In this case, we add the correct guess onto the list of guesses, and that'll be useful later on. Okay, so we've got two things left here. We need to show the user's progress, and we need to check if they've won or not. If we run the program right now, there's no errors, but it's not really doing anything. It's just expecting us to input something 10 times and then it will exit. So in order to see what's going on a bit better, let's look at this showing the user's progress. Now, this is actually a bit of its own little sub-problem, really. It's not quite as simple as you might think. And what we really want to do is look at each letter that's in the word, and if it has been guessed, we want to print it out, and if it hasn't, then we just want to print a dash in its place. So to do this, we're going to introduce a new kind of loop, and it looks like this. Letters.each space do, and then in between pipe characters, which is a character you may not have even used before if you've never done any programming. Usually it's on the same key as the backslash, space letter, and then another pipe, and then I'm going to put the word end in before I forget. So this kind of loop is used to look at each item on a list. And the reason we have this pipe, letter, pipe here is because computers are really stupid. They, unlike us humans, can't figure out that each item on a list called letters is called a letter. So we have to be explicit and tell it what each item is actually called. So for now, let's just output the letter. And we'll run our program and see what happens. So we get the word monkey printed out, but each letter is on a new line. So it's doing something, and there's no errors, which is always good, but it's not really quite what we want. What's happening here is the puts method actually adds one of those invisible new line characters that we talked about in the very first program onto the end of whatever text you give it. And in most cases, that's actually exactly what we want. When we print the instructions out, we want everything after it to appear on the next line. But in this particular case, it's not what we want. Thankfully, the puts method has kind of a cousin method, I suppose you could say, which is print, which doesn't add that new line character on the end. So now when we run the program, we can see it says the word monkey. And as we guess things, nothing really happens, but it continues to print it. So at the moment we're printing a letter every time, but actually we only want to print it if it has been guessed. So let's wrap it in a conditional. So I'm going to say if guesses, which is our list of correct guesses by the user, include the letter, then I want to print the letter, and I'll put the end on the other side of it. Let's see how that looks. So to start off with, we get no output. If I guess an H, nothing happens, but as I guess an M, an O, an N, a K, an E, and a Y, the word monkey gradually appears. So we've improved things slightly. All we have left to do now is to add an else part to this conditional, in which we will print a dash. Let's see how that looks. Great, so we've got 6 dashes, and as we guess the letters, they gradually fill things out, which is exactly what we put in our comments here. So everything's looking good. So we have one comment left sat here by itself that we haven't done anything with yet, which is to check if the user's won. So by now we should have everything that we need in order to do this. We have the list of letters that's in the word, and we have a list of correct guesses. So in theory at least, we can just compare these two lists, and if they're the same, then that means the user's won. So let's give it a try. So let's say if the guesses is equal to, a double equals remember, the letters, we will say puts, you win, and then we'll break out of this loop because we don't need to continue asking for guesses if the user has won. So let's give it a try. So I guess M, O, N, K, and E, and a Y, and it says you win. Great. So everything seems fine, except maybe it isn't. See what happens if we guess the letters in the wrong order. Now it doesn't work. And the reason it doesn't work is because the two lists, the list of letters and the list of guesses, they're different. Let's see what happens if we compare the two lists 1, 2, 3 and 1, 2, 3. Now the result is true. But what happens if we make the second list 3, 2, 1? We can see now the result is false. So order is an important property of lists which is taken into account when you compare them. So in order to do this comparison, one of the easiest things we can do is to actually sort both of these lists. And we can do that using the sort method that lists have. So if we change this conditional to read if guesses.sort is equal to letters.sort, and try again, O and N, K, Y and M and an E, it says you win. Great, that particular bug is fixed. Now, at this point it looks like things are pretty much working, but I think there's some small improvements we can make, and there might even be some bugs lurking in there too. So the first thing I want to add is pretty small, but we never actually get to see the word monkey written out in full, and that doesn't feel very satisfying to me. So before I say puts you win, I'm also going to say puts word, which will output the original word. Let's give that a try. K and E, Y and M. Great, monkey, you win. That's much more satisfying. Okay, so just like in the last game, where we started off with a fixed number to guess, we have a fixed word to guess, which isn't very interesting, and if it's always monkey, you're pretty unlikely to replay this game. So in order to fix that, I'm going to wrap the word monkey up here in square braces to make it into a list with one word on it, and then in the end I'm going to put .sample. Sample is another method that lists have. It gives you a random item from that list. So at the moment when we run this program, everything's the same, but now we can add more words into this list. So let's say giraffe and give that a go. So this time it happens to be monkey. That's fine. And this time it looks like it's giraffe, so let's give that a go. An A, F, an E, an I, and an R. Oh, so something strange is going on here. And what this is if we guess F again, it says that we win. So there's a slight problem still with our conditional down here where we're checking if the user has won, because we don't take into account the fact that there might be two instances of a particular letter in the list of letters, but not in the guesses. And indeed we would actually have the opposite problem should we guess the same letter twice in a word that doesn't have repeated letters. So here I guessed the letter O twice, and now we can't win. So to solve that, we're going to use a method on these lists which removes the duplicate items, and that is .unique. Not quite the full word unique, just UNI and a Q. So that method removes the duplicates from these lists. So how this line reads now is take the list of guesses, sort them, remove the duplicates, and compare that to the list of letters sorted with the duplicates removed. Let's give it a try. So this looks like the word monkey, so I'm going to guess the letter O twice again. E and a Y, and that worked. Great, we win. And now it looks like the word giraffe, so let's give this a go. A G, an R, an A, an F, and an E, and an I. You win. Great. That problem's solved too. So there's really one more thing I want to add to this program before we finish, and that is the user only gets 10 guesses every time, regardless of whether they guess the correct letters or the incorrect letters, which I don't think is very fair. In particular, if the word was quite long and had more than 10 letters in it, it would be impossible to win. So instead of that, I'm going to change things around a little bit to make it so that the user has a certain number of incorrect guesses before they lose, instead of a fixed number of guesses every time. The way I'm going to do that is before the loop, I'm going to make a variable called guesses_left. And I'm going to set it to 10. So the user starts with 10 guesses. And then each time we go through the loop, the very first thing I'll do is check to see if the guesses_left variable is equal to 0. And if it is, I'm going to say that's too bad. And then I'll break from the loop. So at the moment, this won't quite work as we intended because we're still using this 10.times loop. But I'm just going to change that to the word loop. So we have loop do. And this is what you would call an infinite loop. It will keep going until you call the break keyword somewhere inside it, at which point it will stop. You may have heard of infinite loops as being a bad thing and something that you should avoid, and yes, that's true in some circumstances, but in this case it's exactly what we want. So if we run this program, things aren't going to quite work the way we want, and in fact I can just keep guessing the wrong letter over and over and over and over and over again, with no ill consequences, so we're not quite there yet. The thing I need to do now is to say, if the user guesses incorrectly, subtract 1 from the guesses_left variable. So I can do that down here, where we check if the guess is in the word. If it is, we store the guess. We can add an else part to this conditional, in which we say guesses_left is equal to guesses_left minus 1. And if you happen to be a programmer already watching this video and you know that there's a shorthand for this, yes there is, but in this case I think this is perfectly readable. So let's give that a go. So now I'm going to try and deliberately lose this game. Z, an H, C, a V, a B, too bad. Great, so that works, and just to check that we can still actually win the game, which we can too. Great, so everything seems to be working. So this is quite a big step up in complexity from the last program, and I think there's a couple more things that you could do to improve it. For example, at the moment, if you guess an uppercase letter, it doesn't work. You have to guess the lowercase letter. But I think there's a way, there's definitely a way to solve that, and I'm going to leave that as an exercise for you. You might have to do some Googling around, but the thing you really want to do is turn the guess that you get from the user to the lowercase equivalent every time, so that things always compare well. So I hope you learned something. There might be more videos in this series in the future, but that's it for now. Thanks very much.